Welcome to another flight instruction lesson. This is Flight Instructor Nick. Today we'll be covering aircraft systems, specifically the power plant, the aircraft engine. So to start with, an aircraft engine or power plant produces thrust to propel an aircraft. Reciprocating engines and turboprop engines work in combination with a propeller to produce thrust. Turbojet and turbofan engines produce thrust by increasing the velocity of air flowing through the engine. All of these power plants also drive the various systems and support the operation of the aircraft. Reciprocating engines, which is what we typically have in a Cessna 172. Most small aircraft are designed with reciprocating engines. The name is derived from the back and forth or reciprocating movement of the pistons. We have a horizontally opposed picture of an engine here. But the movement of the pistons that produce the mechanical energy necessary to accomplish work. Reciprocating engines operate on a basic principle of converting chemical energy fuel into mechanical energy. The conversion occurs within the cylinders of the engine through the process of combustion. The two primary reciprocating engine designs are the spark ignition and the compression ignition. The spark ignition reciprocating engine has served as the power plant of choice for many years. In an effort to reduce operating costs, simplify design, and improve reliability, several engine manufacturers are turning to compression ignition as a viable alternative. Often referred to as jet fuel piston engines, compression ignition engines have the added advantage of utilizing readily available and lower cost diesel or jet fuel. The main mechanical components of the spark ignition and the compression ignition engine are essentially the same. Both use cylindrical combustion chambers and pistons that travel the length of the cylinders to convert linear motion into the rotary motion of the crankshaft. The main difference between spark ignition and compression ignition is the process of igniting the fuel. Spark ignition engines use a spark plug to ignite a pre-mixed fuel mixture. Fuel-air mixture is the ratio of the weight of the fuel to the weight of the air in the mixture to be burned. A compression ignition engine first compresses the air in the cylinder, raising its temperature to a degree necessary for automatic ignition when fuel is injected into the cylinder. These two engine designs can be further classified as 1. A cylinder arrangement with respect to the crankshaft, radial inline, V-type, or 2. Operating cycle, 2 or 4 cylinder horizontally opposed engines. Method of cooling, liquid or air.